Okay, this is just like pretty much like the two-step equations that we did. These do contain more application. Okay, let's do a few of these for example problems, and then I'll let you off on your own to do the rest of them. Let's see, let's start out with number 3. With these equations, and even with inequalities, you guys should be putting a line here because I still have an awful lot of students. For example, I'm subtracting 8. I'm having an awful lot of students subtracting 8 to the same side of the equation. Still, students just get confused, and it's a common mistake. Yes. So I'm going to minus 8 from this side, so it means I'm going to minus 8 from the other side. So I get 36 minus 8 is 28. These add up to 0. Be careful. I have to bring down the minus 7y. Please don't forget the minus sign. Still have to get rid of the minus 7, which is being multiplied to the y. It's my coefficient. So I'm going to divide both sides by the coefficient negative 7. 28 divided by negative 7, negative 4. These negative 7 cancel 1. 1 times y is just y. Like I said, we've been doing these for all last week. I think we were doing them too. The only difference is these have negative signs. Let's do another one. Let's do number 7. Okay, number 7. I don't have to, but I should get my fractional terms by themselves first. It makes the problem a little easier. Don't have to, but it's just easier if you do. So I'm going to add 5 to both sides. I'm going to put my dotted line here, or a line, doesn't matter. I'm going to add 5 to both sides. These add up to 0. I'm bring down my k divided by 6, k over 6. Negative 2 plus 5, 3. Now that I've got the fractional term by itself, I'm going to have to isolate that k. So how am I going to get rid of the k? Yeah, multiply by the denominator 6, or 6 over 1. Okay. My 6's cancel the 1. 1 times k is just k. 3 times 6 is 18. Number 8. Here's my equal sign. Here's my fractional term. It's a minus n over 4. So I'm going to subtract 14 from both sides. These add up to 0. I'm going to bring down my minus n over 4. 17 minus 14, 3. I'm going to multiply both sides by my denominator 4, but not just 4. I'm going to multiply by negative 4. I'm going to do 2 steps at once. I bring that negative sign with me, it cancels out this negative sign also. And I get my n. 3 times negative 4, negative 12. I think that'll give you enough examples at least to do the computational problems. Now let's take a look at the word problems. You can't be skipping these. Stop it. Number 13. Sarah is going on a backpacking trip and plans to carry 25 pounds in her pack. She has already packed 18.5 pounds of gear and supplies, and she wants to use the rest of the pack's weight for water. Each bottle of water is a quart and weighs 2 pounds. Right. Let's start over again. Sarah's going backpacking trip and plans to carry 25 pounds. What is this 25 pounds? Remember what I was telling you guys about word problems? Well, besides don't skip them. We usually have, in this course anyway, a total. So the total here is going to be 25 pounds. And that's going to go to one side of my equal sign, right? All right, what's my x going to equal? What's the unknown here? What does she want to bring with her? Water. How many bottles of water, right? We don't know. So this is going to be the number of bottles of water. Okay. What does this 18.5 pounds represent? Much as she already has. So she's adding 18.5 pounds to it already. She's going to add some bottles of water. But don't forget we're dealing with pounds here. 18.5 pounds, 25 pounds. How much is each bottle of water? 2 pounds. Got it? So there's my equation. All right, part B says to solve it. Well, here's my dotted line. I'm going to subtract 18.5 from each side. So I get 2x equals 25 minus 18.5. See, that would be 7, but we got a minus a half, so it's going to be 6.5. Then I'm going to divide both sides by the coefficient 2. How many bottles is she going to be able to bring? How about 3.25? 3 1/4. I would, as a real life problem, it would be 3 bottles. But you can't really bring. Just fill up one bottle a little overflowing. Carry the rest in. Let's see. Turn it over. 14. Problem number 14 and 19 are the same ones. Same type of problems. So I don't care. I'll do 14. Susan had a $10 coupon for the purchase of any item. She bought a coat that was on sale for 1/2 of its original price. After using the coupon, Susan paid $125 for the coat before taxes. What was the original price of the coat? So now this is easy to figure out what the variable is, right? What was the original price of the coat? That's your variable. What's going to be my total here that I'm going to put on one side of the equal sign? Yeah, 125. She paid $125. That's her total she paid. So I'm going to put that on one side of my equal sign. Okay. Now, when you use a coupon, do you get money added to your total or less or subtracted from it? So I'm going to take it off of what I paid. And so I'm going to subtract $10 of what I paid. Okay. Now, she only paid 1/2 of the original price. What's the original price? What's the original price? What's my original price? What's my original price? I think I heard somebody say it. X. It says it right there. X equals the original price. At least he's trying. Okay, 1/2 x minus 10 equals 125. Now I'm going to just solve for x. Add 10 to both sides of my equation. And you were right, 135. You were just a little ahead of me. And how do I get rid of that denominator too? Multiply it by 2. Does that equal? Yeah, the cost of the coat was more than 170, it was 270. Okay. You guys are really going to have to pick apart these word problems. There's just no way around it. I like picking students apart. Better yet, I like picking on. Okay, number 15. Let's see, I've got 53 plus, it's my addition sign, 4 times n. I don't really need a multiplication symbol there. Is as much as 21. So what is as much? Equals. Okay, because I've read the directions, I know that not only do I have to write an equation, I have to solve an equation. So, we're going to solve this. Got to subtract 53 from both sides. I get 4n, thank you, equals negative 32. Going to divide by the coefficient 4. So n is going to equal negative 8. I'm going to do one more. Number 16. What does the word quotient mean? Divide, right? A lot of you put multiplication on your test. Okay, the quotient of x and 4, so x divided by 4, you can use the division symbol, minus 6 equals 15. Okay, solve the equation. Gotta add 6 to both sides. So I get x over 4 equals 21. Multiply both sides by the denominator 4, or 4 over 1. And I get x is going to equal 84. Hey, you're on your own. Number 21 is kind of a really different problem. So if you can't get it, there's a reason for it. It's a strange problem. It's not set up like what we've done in the past. Give it a try, and see how you do. Yes. 21 times 4, did I screw up? Multiplied by 4.